Okay. Hopefully we'll get most of it done at this point because it should go pretty quick. Next, you got the factoring. The only bad thing about the factoring is that I don't tell you what kind of factoring it is. You're going to have to identify it. So you're going to have to practice knowing what kind of factoring looks like. You know, what are your clues? Always, always, always start by trying to find the GCF. There may not be one, but look for it just in case, because that's typically the easiest thing to find. So on the very first one, is there something that you can take out? Is there anything that's common? And if so, you want the biggest thing. Well, you got 16 and 8, so the biggest number in both is 8. For the M's, 8 doesn't have one, so you can't take an M. So 8 is it. So go through and tell me what remains when you divide out the 8. Because remember, we divide the coefficients. So divide coefficients. And then we're going to subtract the exponents of variables. So that's pretty much how it works whenever you're doing GCF. Okay, so 16 divided by 8 is 2. You didn't mess with the M, so bring it down. You didn't mess with the plus sign either. 8 divided by 8 is 1. You do have to have that 1. So if this original is a binomial, in here has to be binomial. At that point, you're stuck. So that's your answer, move on. All right, we get to the next one. Well, that sure is a bunch of stuff there. I'm assuming there's a GCF because that just looks like alphabet soup. So look at your numbers first. You got 4, you got 8, and you got 10. The biggest number that goes into them all is 2 because they're all even. All right, now look at your X's. Remember our little cheat. Everybody's got an X. Now the way you can tell how many you can take out is the smallest power. Well, the smallest exponent for X is 2. And now look at your Y's. Well, everybody's got one. So the smallest exponent is 1. So take one Y out. And then you're going to tell me what's left. Okay, remember, divide coefficients, subtract the powers. So 4 divided by 2 is 2. He had 2 X's, I took them. So he didn't have any left. So then he had 5 Y's, I took 1. So that leaves him 4. Now move on to the next one. 8 divided by 2 is 4. He had 3 X's, I took 2. So there's 1 left. He had 2 Y's, I took 1, so there's 1 left. Move on to the next guy. 10 divided by 2 is 5. He had 4 X's, I took 2, so that leaves 2. He had 1 Y, and I took it, so he doesn't have any. There's nothing I can do with that inside. That's just a mess, so that's my answer right there. I'm done. Okay, when you get to number 3 and you look at it and you're like, well, so far I've been doing a lot of GCF, so is there anything common between 27 and 64? No, there's not. The only thing that goes in 27 is 1, 3, 9, and 27. And 64 is a bunch of even numbers, but 3 and 9 doesn't do it. So is there anything else that catches your eye? Well, it is a binomial. It is subtraction, but it's not a square. So it's not a difference of 2 squares, but that is a cube. So hopefully that catches your eye. So this is the difference of 2 cubes. So I'm just going to come down here so I've got a little bit more space. Remember, it's a binomial and a great big trinomial. You've got to do cube roots on the front. So what is the cube root of 27? So what number times itself 3 times gives you 27? That would be 3. And then you've got to do the cube root of x cubed is x. All right, so then the cube root of 64, what number times itself 3 times gives you 64? That would be 4. Don't mess with the signs just yet. Remember, that's the icing on the cake, last thing. We are going to construct this trinomial using these 2 items. Okay, so the first term is whatever is in the front. You're just going to square the whole thing. So think about all of that squared. So that would be a 9x squared. Okay, for the middle, right here, that's the product. So multiply those 2 things together. That would be 12x. And then when we get to the end is going to be whatever this thing is squared. So 4 squared, that'd be 16. And if you're remembering, the signs go by SOP. So the same as the original. So the original was minus, so we're minus here. Then O stands for opposite, so that would be a plus, and the P stands for positive. So that is our answer right there. So you can box it out, you're done. Move on. Okay, next problem. Well, is there a GCF on number 4? Well, you can't take a number because the first term doesn't have it. You can't take a letter because the last term doesn't have it. It's a trinomial, And since there's nothing in the front, that means this thing is an easy trinomial. So just read it from the back. So we know we're going to have x's in the front, or at least I hope you do, because that's the only thing. X times x gives us x squared. Okay, so reading from the back, what are two numbers that multiply to 45, and this sign says subtract to give you 4? Well, multiply to 45, they got to be kind of close if they're going to subtract to 4. That would be 5 and 9. Signs are different, and the big one is positive. So 9 gets the plus, 5 gets the minus, and you're done. Okay, well, number 5, is there a GCF? No, because the first term doesn't have a number and the second term doesn't have a letter. So you can't take anything common out. I see a binomial. That binomial is subtraction, and that's x squared. Ooh, I can do the square root of 100. So that means this is the difference of two squares. Okay, so that means you're going to do two sets of parentheses, and you're going to do the square root of the front and the square root of the back, and your signs will be different. It doesn't matter which one's plus and which one's minus, just make sure you got one of each. And that's your answer. Okay, moving right along, number 6. Is there anything common with 8 and 125? 8. That'd be 1, 2, 4, and 8, 125. I think that's like 525. There's nothing in common there. And the first guy's got A's and the second guy's got B's. Well, you can't pull anything common. But I see cubes. And it's the sum, but you can do the sum of cubes. So it's that same rule that we did on number 3. So get a little set of parentheses and a big set. I'm going to go faster than number 3 now. So the cube root of the front is 2a, that's a 2 by the way, and then the cube root of the back is 5b. So remember how we construct this. We got a trinomial here. We're going to take the first one and we're going to square both pieces. So both factors there get squared, so that would be 4a squared. In the middle, you're going to do the product of those two, which is 10ab. Just put your variables in ABC order. And in the back, you're going to square your last term. So that would be 25, and don't forget to square your variable. And then sop out your signs. So it starts with a plus, so plus goes here, opposite, always positive there. So you're done with that one. Okay, moving right along. Go to number 7. Is there anything common? No, there's not. Nothing in the front, not a number in the front, and there's not a letter in the back. The fact that there's not a number in the front means that this thing is an easy trinomial, which means you can just read it from the back. What two numbers multiply to 15 and add to give you 8? Well, that would be 3 and 5. Signs are the same. Both of them are plus. And you are done. All right, so when we get to number 8, is there something common? Well, I'm looking at 3 and 5. They're both prime. That doesn't work. Aha! There are x's in both of them. How many x's can you take? Let's see here. The smallest power is 3. So, out of the first term, I didn't mess with his 3, but I took 3 of his x's, and that left him 2. All right, and then I didn't mess with his 5, but I took all of his x's. And you are factored. Okay, for number 9, there's nothing common because the first term doesn't have a number, the second term doesn't have a letter. It is a binomial. It's plus, though. And it's squared. If it had been cubed, I could have worked it like number 6, but that's a square. And remember, for squares, it's difference of two squares, not sum. So this one is sneaky, sneaky. He's prime. Okay, so keep going. Number 10, is there something common? 16, 25? No, first guy's got x's, second one's got y's. There's nothing in common. It is a binomial. It is subtraction, and oh, I can do the square root of everything. So this is the difference of two squares. So square root of the first, square root of the second, and then your signs are opposite. As long as you got different signs, it's all good. Okay, so then we're going to number 11. Is there something common? 3, 10, and 8. No. 3 doesn't go into either of those. So since it has the 3 out front, and you can't take out anything common, this makes it the hard kind of trinomial. So this is that monkey face. So you're going to have to do your little swoopy things underneath. So what two numbers do you want to use to multiply to 3? Hopefully you said 3 and 1 because 3 is prime. Okay. For 8, you actually have choices. You've got 1 and 8, you got 2 and 4. But I did advise y'all the other day to go with the ones that were close. Now we want to rig this so that our middle terms right here will subtract to give us 10. So that means one of them's got to be pretty big. So I'm purposely going to match the 4 up with the 3, because that's going to give me a 12x. Well, that puts the 2 here, so 2 times x is 2x. Does 12x and 2x subtract to 10? Oh, why, yes, they do. So I got everybody in the right spot. Go back and do your signs. There's a minus in the back. That means that these signs are different. And the big one of these things down here, 12 is the big one, he's the one that gets the minus sign. Well, who helped make it, the 2 or the 4? Well, if you follow this line back here, the 4 helped make it. So put the negative there and the positive there. You can leave your answer just like that, or you can just come straight in here and just put a box around that thing and you're done. Same kind of problem right here for number 12. You can't take out anything common, but that 5 is going to make it one of the monkey face problems. So the two numbers for 5 would be 5x and 1x. For 7, it's still prime, which is awesome because it takes your choices down. The only question you've got is which way you do it. Do you do 1, 7, or do you do 7, 1? Now we want our middle terms to subtract to give us 2. So I don't want the 7 back here to multiply times 5. That gives me 35. That's way too big. So put the 7 up front, and that'll give me 7x, and then 5x times 1, it would be 5x. So look at these two little things. Do they subtract to give me 2? Yeah, they do. So that means everything's in the right spot. Signs are going to be different, and the big pair is going to be negative. Okay, now the big pair, remember we're talking down here. So that, who helped to make it, the 7 or the 1? Well, on that little swoopy, that's the 7. So put the negative there, and the other one gets the plus. And again, you can just come in here and just put a little box around it. You don't have to rewrite it or anything. That's all you need. Okay, number 13, I obviously have a typo. Y'all's paper is correct because it's got y squared there, which is the way it should be. This one is actually an easy trinomial. You can't take out anything common because the first guy didn't have a y, and then the last guy didn't have an x. The first guy didn't have a number either. So it's actually an easy trinomial. Think of it that it works like this: x squared minus x minus 20. So it's going to work the exact same way. We're just going to put y's on the back end of our numbers. So what two numbers multiply to 20 and subtract to give me 1? So I got x and x, and that would be 4 and 5. And it says the signs are different, the big one's negative. Oops, I forgot my y's. So squeeze them in. If you forget yours, just come in there and squeeze them in, you're all good. Okay, next one. It's an easy trinomial. Multiply to 36 and add to 12. So that would be 6 and 6. Signs are the same, both plus. So you can leave it like that. MathXL may have been asking y'all to squish it up and put the square out there. I'm not quite sure. All right, this one, trinomial again, can't take out anything common. So once again, we're doing the hard kind. What multiplies to 3? That would be 3x and x. Now for 6, we do have options. We could do 1 and 6. We can do 2 and 3. But we need to subtract to 7. So I got to get bigger than 7. So, but not too big, you know. So I'm going to purposely match the 3's up. That gives me 9. And that leaves me 2 right there. Do these two things right here, subtract to 7. And yes, they do. So everybody's in the right spot. Signs are different. The big term is negative. The big one is 9. Who helped make him? 3. So he gets the minus, and that one gets the plus. Okay. Now, we do have the factor completely section left, but I'm going to put that in a separate video. So I'm just going to go ahead and wrap this one up. And if you want to see the factoring completely, you're just going to have to hit the next one.